This video is going to show you how to do some confidence interval problems by hand, i.e. those that don't require SPSS. So if you turn to page 149 or so in your course packet, I'm going to do problems 1 and 2. So 1 is about means, 2 is about proportions. So let's take a look at number 1. A market survey has shown. Okay, so we should note that this whatever this problem is about is coming from a survey, as opposed to here's the truth, here's the parameter. So note that the survey has shown that the average is $15.48 that our customers will spend. All right, so this is an X bar, not a mu. In the previous chapters, the problems have been giving us mu's. Here they're giving us something from a sample, which means that this is an X bar. So we should go over and take some notes at this point. And X bar is $15.48. Now this is based on a survey sample of 483 people. So let's go write that down as well. N is 483. The standard deviation of the sample. So standard deviation of the sample is the random variable S. This was found to be $2.52. So S is $2.52. We're to find a two-sided 95% confidence interval. Well, when you're finding confidence intervals, the first thing you always want to do is find the standard error. So the standard error is S sub X bar in this case, and that's going to be $2.52 divided by the square root of 483. And so if you do the math on this, you get that the standard error, that's an equal sign there, is 0.1147. Now, a 95% confidence interval is always the estimate, $15.48. If you want to attach a dollar sign, you may do so. And it's always plus or minus two standard errors if you want a 95% confidence interval, or you can also say 1.96, which is a slightly more precise version of 2. So this is going to be two standard errors, 1147. And then if you look at this piece right here, it works out to be 0.2247 or 0.22 something or other. All right, so that is the margin of error. This is the standard error. So this is the standard error. This is the margin of error. And then this whole thing is the confidence interval. Let's go on to problem 2 now. Problem 2 says that you have a recent survey of 252 customers. So if it's a survey, we know that N is 252. So we have interviewed 252 people from a large database. This survey found that 208 are satisfied with the service that they're receiving. So it sounds like the opposite of being satisfied is not being satisfied. So we have a dichotomous event here. 208 is the number of yeses. So that's really an XB. You can think about, we flipped a coin 208 times or 252 times and observed 208 heads. Now we can compute from these the value of P. P is the proportion of yeses, a proportion of satisfied customers. So 208 divide by 252, and this works out to be about 82.5%. Well, let's go read on. Find the 90, the 95, the 99, and the 99.7% confidence interval for the percentage of all satisfied customers. Well, again, we want to find the standard error. So in this case, it's S sub P. S sub P is going to be P times 1 minus P over N. So 0.825 times 1 minus 0.825 divide by N, which is 252. All that sits under the square root sign. And this works out to be 1. I want to make sure I got the right number here. It's 0.02. Let me get rid of this. Got lost in my notes there for a second. 0.02391. Now we're asked to find the 90, the 95, the 99, and 99.7% confidence interval. So let's start with the 90% confidence interval. It's just going to be 0.825, and then the 90% tells us that we have to use a z-value of 1.645. So that indicates use that z-value and then use the standard error, 0.02391. So again, it's the same thing we did previous problem, your estimate plus or minus some z-value times the standard error. Well, here's your z-value times the standard error. I'm going to actually write out what this is. So this is about 0.79 to 0.86. So this tells us that we have this give or we think that the true proportion of satisfied customers is somewhere between 79.86% and there's a 90% coverage probability. So if we could repeat the sampling procedure many times, 9 times out of 10, this confidence interval would cover the true value. We'd get different confidence intervals every time we did a different sample of 252, but 9 times out of 10 that would cover it. Well, let's look at the 95% confidence interval now. It's just going to be roughly the same thing. So 82.5 plus or minus. The difference is we're going to use 1.96 rather than 1.645. And if you work this out, you'll see it extends now a little bit further. So that should make some intuitive sense to you. If you want to have it to cover it 19 times out of 20 instead of 9 times out of 10, it's going to have to be a little bit wider. And sure enough, you'll see it extends an extra percent in either direction. Okay, what about a 99% confidence interval? Well, same thing, 0.825 plus or minus. This time it's going to be 2.576. There's a 7 in there that I missed. Why don't we redo that? So 2.576 times 0.02391. And this time it's going to get, you would expect it to get even bigger, and sure enough it does. So 0.76 to 0.89. And then a 99.7% confidence interval. Remember, 99.7% of the data fall within 3 standard deviations of the mean if you go back to the empirical rule. So therefore the z-value is going to be 3. And you would expect a wider confidence interval yet, since the confidence level is higher, and sure enough it now stretches from 75% all the way up through 90%. Okay, I would suggest that you maybe try these problems on your own and try some other problems from Chapter 9.